Okay guys, so here's the video that I've been telling you guys that I was making. So here we go. The question reads, a hockey player is racing across the ice at a velocity of 10.5 meters per second. The player misses the check and strikes the board, stopping all motion. If he skated 12 meters across the ice, calculate the force with which he strikes if he has a mass of 91 kilograms. Okay, so there's a couple of things in here that you have seen already, but you probably don't remember. It seems like a lot, and there's probably some new things in here that doesn't look familiar, but I can assure you that you've already seen it before. So we're gonna go ahead and start looking at everything that we have here. Okay, so the first thing I want to point out is obviously we have values here, we have values here, and we have a value here. Even if you don't know exactly what that means yet, that's okay. So let's go ahead and get started. And we're going to start by listing our givens. Now, I'm going to go ahead and just take my little red pen here, and I'm going to underline the things that are very obvious, right? So the first thing I see here is we have 10.5 meters per second, right? Player misses the check, strikes the board, stopping all motion. If he skated 12 meters across the ice, I'm going to underline 12 meters. Calculate the force with which he strikes if he has a mass of 91 kilograms. Now you're probably thinking, hey, mister, I've never seen this 91 kilograms, but I promise that you have. It's not going to be any harder. We're going to go ahead and take it a step at a time. Okay, so the first thing I see here is I see that I have a velocity, right, of 10.5 meters per second. So I'm going to go ahead and list that. Meters per second. Okay, and I know that's a velocity because of the meters per second. Next thing I see is I have 12 meters. Because it's meters, I know that I have a displacement, which is going to be equal to 12 meters. Alright. And then the last thing that we have that's pretty obvious here is the mass, which is, I'm going to put that in a different color. Mass is equal to 91 kilograms. Okay. I'm putting a different color because that's going to be a different formula that I'll show you guys in just a minute. But I'm going to go ahead and list it because it is a given. Now, there's a couple other things here that are listed that may not be very obvious to you, but they are here. For example, it says here, strikes the boards and stopping is the key word, all motion. So if you're moving at some velocity and all of a sudden you stop, what does that tell you about velocity? Well, it tells you that some velocity is going to be equal to 0 meters per second, right? So that's my next given. Now, which one of these givens, or which one of these velocities is going to be your initial and which is going to be your final? This is your final, or this is your initial, or vice versa? Well, if you're traveling at some speed, right, and then you come in collision with something and your speed stops, well, becomes your initial velocity, and then your final velocity becomes at 0. So I'm going to go ahead and just separate these now and say that this is my initial velocity and this is my final velocity. Alright, I'll go ahead and give you guys a second. If you need to pause the video, go ahead and pause it now so you can go ahead and write down these notes. Okay, now before we go on, I did notice that I made a little bit of a typo here, so I'm going to go ahead and just add that 1. That's 91 kilograms, not 9, so I apologize for that. Now, in order to move forward, we need to figure out exactly what the question is asking, right? Basically, it's telling you right here, right, that it's looking for us to calculate the force. The force is the key word, so I'm going to go ahead and underline that real quick. That's our key word. Now, if you remember or not, I don't know, but just know that the force, right, is equal to some mass times an acceleration, right? Now, we have a mass, right? It's here. What we don't have is the acceleration, and that's where the kinematic equations come into play. Right? We need to be able to calculate the acceleration so we can find the force. We can't find the force without acceleration, and we need the kinematic equations, which are these guys right here, to figure out which one of these we're going to use to find the acceleration. Now, this is what we're given. We're given an initial velocity, a displacement, and a final velocity. Now, a lot of these equations have initial velocity, final velocity, displacement, etc., right? So what we need to do is we need to figure out which one of these has acceleration, right? Which one does not have acceleration, and which one does. So just start off with, right? We can't use this one because there's no acceleration, right? We're looking for acceleration, so we need to have one with acceleration. Now, the other thing that I'm seeing here is that we don't have a time. So we have to eliminate any one of the equations that has time because we don't have a time. Right? So once you eliminate those, what's the only equation you're left with? Well, this one, right? That's going to be our equation. It's the only one that has a final velocity, initial velocity, a displacement, and the variable we're looking for, acceleration. So the formula that we're going to be using for this is going to be VF squared is equal to V naught squared plus 2a delta x. Now, first thing you got to ask yourself is this equation set up to find acceleration? No, it's set up to find final velocity. What we need to do is we need to solve it or change it to find acceleration. So I'm going to go ahead and continue that on the next slide. Alrighty, so here's our formula. We said it was going to be formula is equal to final velocity squared minus initial velocity squared. Is equal to initial velocity squared minus 2a delta x, and we need to solve for a. So let's go ahead and get started. This is the guy we're looking for, so we're going to start getting rid of everything else. First thing we're going to do is we're going to subtract velocity on both sides. All right, that cancels here. Therefore, we are left with final velocity squared minus initial velocity squared is equal to 2a delta x. All right, so therefore, I'm going to go ahead and rewrite that now. Vf squared minus v naught squared is equal to 2a delta x. All right, so now how do I get rid of the 2 and the delta x? Well, what I'm going to do to cancel that on both sides is I'm going to go ahead and divide both sides by 2 delta x. All right, the 2's cancel here, the x's cancel here, and I'm left with acceleration is equal to vf squared minus v naught squared all over 2 delta x. All right? That's what you have to do. You have to figure out what is the formula you're looking for, okay? And then once you have that, solve for the correct variable, and then just plug in your values, okay? So I'm going to find my acceleration. So my acceleration is going to go as follows. My final velocity we said was 0 meters per second squared, meters per second, and I'm going to square that, minus my initial velocity, which was 10.4 meters per second squared. And I'm going to divide that by 2 times the displacement, which in this case was 12 meters. All right, so I'm going to go ahead and give you guys a second to write that down. All right, pause the video if you have to, and then we'll go ahead and pick it up. All right, make sure that you have this written down, because I'm going to go ahead and just shrink it a little bit so I have more space to work. I'm going to put it over here to the side. Okay. So let's go ahead and continue where we were. All right, so I'm going to go ahead and just start simplifying here. I know that acceleration is equal to 0 squared is going to be 0 meters squared over second squared, minus 10.4 squared is going to be 108.16 meters squared over seconds squared, right? Because I've already squared that. Divided by 2 times 12 meters gives me 24 meters. All right. So because these guys are like terms, right? They're meters squared over second squared, right? Here and here, I could just subtract these. So 0 minus 108 gives me negative 108.16 meters squared over seconds squared. And then I'm going to divide that by 24 meters. Okay, go ahead and pause the video if you have to, so you can go ahead and write this down, and then we're going to go ahead and move on. Hope you have it. So what's going to happen is we're going to go ahead and take 108 and we're going to divide it by 24, 108.16. That's going to give us a negative acceleration of negative 4.506 meters per seconds squared, because the meters cancel one of those meters there, and I'll show you how in just a second. Alright, so A, or acceleration, is negative 4.506 meters per seconds squared, and that is my final answer for this part anyway. Alright, so just real quick to show you how the units work. Alright, I have meters squared over second squared minus meters squared over second squared. That obviously just becomes meters squared over second squared, right? Because they're like terms. And then I'm dividing that by meters over 1. When you have a complex fraction, you multiply by the reciprocal, right? Which becomes 1 over m. And because these guys here are across from one another, the meters here and here are across from one another, then they cancel each other out, right? So this meters will cancel the squared, and you're left with meters per seconds squared, which is the unit for acceleration. So that's the proof for the units. Now, are we done? Almost. The question was asking originally, if you remember, was with what force did the player strike? All right, so I'm going to go ahead and just erase this here. So if you need to pause it, go ahead and pause it, because I'm going to remove it. So the original question was force. With what force did he strike? Well, we know that force is equal to mass times acceleration, right? So we know the player's mass. Remember from the question, the mass was 91 kilograms. And now we know the acceleration, right? We just calculated the acceleration. It's 4.506. Right? Now, in this, because force doesn't really have a direction, you can leave off the negative, right? It's just, that's the acceleration. Whether it's positive or negative doesn't really matter for the force, because it's still going to be the same, right? So, according to the formula, all you have to do to these numbers is you have to multiply them. So, 91 kilograms times 4.506, right? This is meters per second squared, by the way. Right? Gives me a force of 410.046 kilograms meters over seconds squared, or you can say 410.046 newtons is equal to the force. And there's your answer. Okay, now with the video, you can pause it, you can rewind it, you can watch parts over and over again. If you can't remember the givens, go back, rewind it, and watch it again. If you have any questions, let me know. What I'm going to ask from you guys is to show me the notes from this video so you guys can get credit. So I hope you guys were taking notes, and I hope that you're paying attention. All right, if you guys have any questions, let me know.